On the new chapter now, we're going to start 17.1, bearings. So this is something new to everyone. You haven't seen these before, apart from the checkpoint papers, but we've not been able to do them before. So we're going to go through a quick sort of description of what bearings are. We're going to do some examples, and then I'll set the classwork at the end. So it's important to watch these both because this is new to us. Description, just to tell you what it is, and then the examples will really help you out with how to do the questions. So let's get into it. What is a bearing? So a bearing is going to describe where one object is in relation to another. So in what direction an object is. So let's pretend we have two objects, A and B. Okay, and you might know, well, you should all know the compass, like this, and we have north, east, south and west. So what direction is B from A? You would say it's east, okay, because it's this way. And that's fairly straightforward, but what happens when we start getting maybe like if B was here? Well, maybe that's southeast, but what happens if it was maybe here? And it starts getting a bit harder and harder. So in maths we use numbers, okay? So bearing is just a direction as a number, and it's got some rules. Firstly, it's always measured from north. Always, and I say starts at north. And if that doesn't make sense to you, just watch for a moment, watch the examples, and it should make sense. So it always starts at north. It always goes clockwise. Measures clockwise. And it's always a 3-digit number. It is always a 3-digit number. So let's look at our simple example again, A and B. We said B's in the east. Okay, so we go from north, always starts at north, always measures clockwise, which is this direction, and it's always a 3-digit number. So we should know what angle east is. It's 90 degrees. But as a bearing, it has to be 3 digits, so we would write 090 degrees. Okay, and what about if C is over here? That's to the west. So we always start at north. We always measure clockwise, so it's all the way around here, and it's always a 3-digit number, so it's 270 degrees. So bit C is still 3 digits, 270. Okay, so let's do some actual examples of questions you'll get, and then hopefully you'll understand. So the question says, what is, I'll change colour, what is the bearing of B from A? So we want B, and we're going from A. Okay, so it's this, you've got to be careful with these questions, because sometimes they're worded in a confusing way. This says we want B going from A. Okay, so I'm going to draw in the norths because we have to start at north. So here we go. Oops. This is north, this is north, and then we want B from A, so it's this angle here we want. And if you're at home, you just get your protractor. It's this angle measurement thing, like this. And you just put it on this angle and measure it. Okay? So I can't do that. So I'm going to have to use this thing and try and figure it out. So that's about 15 degrees for this little bit here. So that means that this is 75 degrees. So what's the bearing? Well, it's not 75, because what are the rules? we have to go from north, which we've done. We have to go clockwise, which we've done, but we have to make it a 3-digit number. So 075. The reason they're always 3-digit numbers is because when they were inputting them in the olden days, they always had a 3-digit sort of counter thing to put them in. So you'd have to put 75, but you'd have to fill this one in with a 0 as well. On like the old-fashioned mapping equipment stuff. So anyway, what is the bearing of A from B? So that means we're going from B this time to A. So we want the angle. We're going to go from north. We're going to go clockwise. And so we want this angle. So again, you can just measure it. So you would probably, maybe you can extend this line down. You know this is 180. And then you can just measure the last little bit and add it on. So this is actually 75 as well. So overall, this whole angle is 255 degrees. And that's already 3 digits. So that's good enough. The way I already knew that was 75, in case you're interested, is because we have two north lines. So they're both parallel. So the parallel line rules work. And this are alternate angles. You don't need to know that, you can just measure them though. But let's look at this one, another example of something you might get. And let's read the questions carefully. In this one we won't be measuring, we'll just have to work them out because it's already given us an angle. So bearing of D from C. So we're starting at C, going to D, because we're from C to D. Okay? So, well, we've already been given the angle. It's 120. It's already 3 digits. So it's from north, clockwise, 3 digits. We don't have to work anything out. Now, bearing of C from D. So bearing of C from D. Okay, so we need to start from north, clockwise. So it's this big angle we want. Okay, so we're going to have to use angle rules now. So we are going to have to use parallel line rules because we're not measuring anything because it might not be drawn to scale. So I'm going to extend this one down. Oops, a bit messy. We know this is 180 degrees on this side because it's a straight line. So we just need to find this little bit and add it on. Okay, and like I said, alternate angles. So this is 120 degrees as well. Or maybe you could do, well, that's the easiest one, I think. You could do, I'll show you another way in a moment. So we'll just add these together quickly. So that's a 300 degrees, and that's your bearing because that's 3 digits. Now, if you didn't like that way, I'll show you another way quickly. So, let's rub this out. This is D down here. The other way you could do it is you could extend this line. We still need this big angle here. This is corresponding to this, and this is on a straight line. So you can still just add them up, get 300. Okay, one last example. Just the same sort of thing, but a little bit different. Bearing of E from F. So we're going from F to E. We're going from the north, going clockwise, 3 digits. It's given us the answer. It'll sometimes do that in bearings. So if it gives you the answer, just write it down. Now bearing of F from E. So we're going from E to F. So we need this angle here because we go from north, clockwise, need this angle. So again, we're going to have to use parallel line rules. How I would do it is extend this. This is 180. So what's this part here? Must be 60. And then alternate angles. This is 60. So the bearing is 0, 6, 0. That's how I would do it. Maybe another way to do it. Oh yeah, the other way to do it would be, let me rub them out. So we knew that this, oops, I'll get a black pen, said this was 240 degrees. So you could extend the line this way instead. Have 180 down here, and then corresponding, oh wait, sorry, I'll do that again quickly, because we didn't know this one yet. We'd have 180 is the straight line, and then what's left over is 60, so then that's corresponding to the 60 here, and again 3 digits. So that's all it is really. You're either measuring, like in the first example, or doing parallel line rules in these examples, and you're just describing the direction things are in. Okay, so for the classwork now, I want you to do all the questions, and then you can try out the brain questions as an extension. From now on, I'll be setting the classwork as assignments on the Google Classrooms. It's assignments, so you can just with a due date, so you know it'll turn up on your to-do list. Due date. So it'll be on your to-do list, but you don't have to hand them in. I'll be putting out the answers, so it's just there to know that you have to do it. Okay. Any questions? Let me know. Put them in the comments or on Google Classroom. Good luck.